In this video, we'll be talking about the new cutting-edge electric engine designed by Tesla that's sure to blaze through its competition. But what is so amazing about this engine that puts it miles ahead of the game? Stay tuned to the end of the video to find out. As you all will be familiar, Tesla Inc. started out and at its heart is still an automobile manufacturer that specializes in both research and development and manufacturing of electric vehicles. From day one, its aim has been to dominate the market and establish complete superiority in the electric vehicle, or for short, EV market. For this purpose, Tesla has worked non-stop in an almost maniacal manner to outlast its rivals, which is evident from the statistics: 5 Gigafactories in 3 different countries in just 16 years, with dedicated factories for production of its battery cells and its associated products like the Megapack, which is aimed to provide backup on a utility level, meaning it can provide backup to a whole grid, underway and quickly approaching completion. Apart from that, Tesla also boasts the Cybertruck, its most futuristic yet most rugged-built product, strong enough to lock horns with America's most powerful pickup trucks, the Ford F-150. With a loading capacity of over 3,500 pounds and a towing capacity of 14,000 pounds, despite all that muscle, it's still as fast as a Porsche 911, reaching 0 to 60 miles per hour in 6.5 seconds. It also features the world's strongest metals used to construct its exoskeleton, the same material being used to fabricate SpaceX rockets. Although considerable delays have occurred during this project and still has not launched yet, Tesla can still play the cards to their advantage. How, you may ask? The answer to that question is the pace of development and research being carried out in the AI and machine learning sector is almost non-stop. Its applications to the automobile industry has captured the interest of many entrepreneurs, and some speculating that a tentative prototype of Level 5 automation might be possible by the end of 2025. Tesla can be the first company that introduces a fully automated driving system, where the driver has virtually zero interactions with the system. And what better way to introduce the technology than the Cybertruck, which has been their most ambitious project till date? That's not all. Tesla is working painstakingly to develop better and better engines that are both environment-friendly, will be powered completely via electric motors, and as efficient as possible. That's why the real icing on the cake in Tesla EVs is its groundbreaking electric motor design that forms the base for its engines. The electric motor in Tesla's new Plaid series is a carbon overwrapped rotor. Developing this motor wasn't an easy task by any means. However, since the machines required to fabricate such advanced pieces of electromechanical equipment didn't exist back then, and all that was there was an idea in the minds of Tesla's engineering team. That's why Tesla not only engineered the motor, but it also built the machinery required to fabricate the motor. Yes, Tesla also built the machine that builds the machine. For this Herculean feat, Tesla Motors instituted Tesla Grumman Automation. Tesla Grumman Automation was originally established as Grumman Engineering in 1963, named after its founder, German mechanical engineer Klaus Grumman. It established its headquarters in Prüm, Germany in the year 1983. Tesla acquired Grumman Engineering in 2017 for $135.3 million, after which it became known to be as Tesla Grumman Automation. Even before it was acquired by Tesla, Grumman Engineering boasted a portfolio of manufacturing machinery for the fabrication of microprocessors, memory chips, airbag sensors, roof seals for vehicles, and lithium-ion batteries on a commercial level for renowned clients. Apart from that, Grumman Engineering also made valuable contributions to the local population of its headquarters in Prüm in the form of training and development of engineering students and technicians via internships and technical training programs. The latest addition to Tesla Grumman Automation's curriculum vitae is the state-of-the-art carbon overwrapped rotor that's set to power Tesla's future EVs. The motor is no less than otherworld technology if you compare it with existing models of hybrid engines and internal combustion or IC engines available and widespread in the automobile market. It's light enough to be picked up by a single person at around 31 kg. It's almost 6 times lighter than a common IC engine. Despite this, Tesla's electric motor can reach 18,000 RPM at close to 90% efficiency at any speed. This is a landmark achievement compared to IC engines who suffer a severe drop in efficiency after 5,000 RPMs. And even at peak efficiency, the rate is only 35%. EVs, on the other hand, can deliver 90% efficiency for most of their operations. While Elon hasn't unveiled much details behind the motor's engineering, however, according to the few details he has provided, fiber is wound over the copper rotor at high tension load. But since copper is a metal and prone to expansion under high temperatures, carbon sleeves are used to keep the rotor compressed. Otherwise, it risks loosening at low temperatures due to differential thermal expansion as it contracts. But how does carbon sleeves help in increasing speed and efficiency of the rotor? The answer is that in traditional motors, the sleeves of the rotor are made from high-strength steels. Steel, being a metal in itself, tends to expand under high temperatures, meaning it will be unable to effectively compress the rotor under high heat compared to the carbon sleeves. This is no rocket science, as it's common knowledge that carbon tends to have a lower thermal expansion coefficient than most metals, who have their thermal expansion coefficients in the double digits, meaning they're more likely to expand under high temperatures than carbon. This increased heat is also detrimental to the magnetic fields being generated, especially in case of steel sleeve compressors for the rotor, as high heat causes misalignment of the magnetic domains of the particles inside the material. This results in a sharp decrease in magnetism, which is a big issue, especially if the aim is to power the car completely on electricity, as reduced magnetism will cause a chain of events. The rotor, and in turn the shaft, slows down, which obviously means the vehicle will not be able to travel at the speeds desired by the user. This loss in magnetism is a especially severe issue if the material in use is metal. However, with an innovative carbon sleeve compressor for the copper rotor, this drawback can be mitigated to a large extent, because it's quite obvious that carbon has a much higher tolerance to heat compared to most metals, especially steel, meaning the engine in a Tesla will tend to stay cooler compared to orthodox IC and hybrid electric engines, which means its effects on the magnetic components of the motor will be considerably lesser when matched with metal sleeves that are commonly used for the vehicle motors. This also translates into a much stronger EM field under high temperatures. This means more consistent engine performance and higher RPMs compared to any traditional IC engine. This is because the carbon sleeves stop the rotor from expanding under high heat more consistently and effectively compared to steel sleeves. If you enjoyed the video, be sure to like it, subscribe to the channel, and turn on your notifications to stay up to date about the latest news and developments in the Tesla universe. Musk has made a bold claim in saying that the Tesla has achieved the world's most advanced electric motor design and in production for large-scale commercial usage outside of any lab. However, this is not the end. Elon, while keeping his secrets, has teased that he has even more exciting engineering stored for Tesla enthusiasts up ahead as he prepares for the launch of the Tesla Roadster. The next milestone for Tesla engineering decided by Elon is reaching higher torque and increasing RPM with advances in Tesla's electric motor technology. Do you think anyone in the EV industry will be able to topple Tesla's insane electric motor design? Who do you think it may be?